Hey guys, welcome back to the last section of Chapter 14 on our discussion of climate alteration and global change. And today we're really going to be focusing on, this photo actually is very specific to what we're talking about today. So this kind of idea of the actual real life changes that occur because of global warming. So we're going to first identify how it's affecting people and the environment, this concept of rising temperatures. And then we'll discuss a little bit about some of the ways we have tried to reduce it over the years. So here are some physical consequences on the Earth. First of all, especially in Greenland and Antarctica in the north, the melting of these polar ice caps. We learned last time that the temperature change is not distributed equally. It's been more highly increasing in the northern hemisphere, but also this does also affect glaciers around the world in general. This concept of melting permafrost, so usually these areas that are pretty much permanently frozen are starting to melt. And then because of that, the idea of rising sea levels due to that melt. So there's a lot of data sets that show these consequences. One is simply by using satellites, you can track the size of these polar ice caps. So here we have Greenland over here, and then here we have the North Polar Ice Cap near the North Pole. And over the years since 1980 in this graph down to ends at about 2009, they have seen a 39% smaller ice cap during the summer. So really significantly smaller region during the summer than we used to see. I went ahead and went to the NASA website to see what it looks like currently. And they have the Antarctica mass and Greenland, so they're checking both here. And notice the rate of change, this many gigatons of ice per year overall. And there was a small gap here. I'm not sure why, but they didn't take data during those years. But you can see clearly that this trend has continued to drop since 2008 or 2009 when that stopped, which was way back here in that data set. And we are still going down and down and down and down. So we're losing a lot of ice. Again, that affects, first of all, habitats like this. That'll mess up the ecosystem here. This ecosystem depends on this polar bear being able to feed off of these ice caps, and then again, those carcasses are left over for other animals, so it's this circular system that can get broken apart. That's just the animal sides of things. Very importantly, though, what happens when the ice melts? We get more water in the oceans, and it might not seem like a lot each year, maybe like a millimeter, but over time, those millimeters turn into tens of millimeters, and you see significant rising sea levels. So this data is back into the 1860s up to past the 2000s, and shows from basically zero, as in just the normal sea level, to the change. But I was also curious, again, I like to look up the new data. So again, this is from the NASA climate website. This shows, though, specifically the region between 1995 to present. So it zooms in on this region, and we see this steady increase. Small fluctuations, as we see over the years, but overall, this is the rate of change per year that we're seeing, a few millimeters per year. So what are the actual, so those are the consequences to the environment, right? This is what's happening in the actual environment itself. And how does that translate to I would say more global type of effects, and that really has to do with these global temperatures. So you're getting more heat waves, more really hot summers. You're getting less of these cold spells. This can actually be bad because a lot of times that cold keeps insect populations down, or specific types of insects only live at certain types of years, or things like mosquitoes. So you do want the cold spells as well. And then it messes with our weathering patterns. So certain parts of the world will get more rain, certain parts will get less rain. The storm intensity, the scientists believe that because of this intense storm patterns that are increasing, this is a reason why we're seeing so much more hurricanes, really intense hurricanes lately. And then global shifts in ocean currents. This can have huge effects on the weather system and also just the actual ecosystem of the ocean itself. So actual living organisms, we've been talking a little bit about this, but plants and animals, not just animals, we can kind of predict what would happen, and also we're not actually sure. There's a lot of unpredictable consequences for this idea of increasing temperature, increasing sea levels throughout the world. So that's kind of a concern as well. The growing seasons can be changed. So you can get longer in some areas, maybe that's good, but more importantly, shorter in different areas, which is really bad for that area. And then also the migration issue. So if these organisms can't migrate like they normally would to a cooler or warmer climate, they have to keep going farther and farther away, or maybe they just can't even make it that far. They'll end up dying off, or end up messing with. If they go to a new place, they could affect that ecosystem as well by overpopulating different areas. Now, the human side, the coastal cities, this is going to be a huge issue. Places like New Orleans, coastal cities that are already dealing with a lot of flooding and dealing with a lot of weather. It'll be an increasing amount of issue for them. And there's a lot of coastal cities in in Southeast Asia, things like that, that depend on being able to live in those areas. So that is a huge issue. Again, mosquitoes carry a lot of diseases, and that could be increased by the rising temperatures. Mosquitoes are going to enjoy more open water and flooding, and they're going to enjoy these higher temperatures. Because of the rise of mosquitoes, those could spread to areas like the southeast United States, who they don't typically have to deal with this type of thing. Usually those are really only in tropical areas or over in Africa, but if these could start coming to the United States, that is another huge health issue. And on top of that, it's all the economic consequences. So a lot of issues, and again, it's complicated, it's interdisciplinary. That's what environmental science is all about. Trying to understand how all of this is connected to something that like global warming that affects the whole world. So I'm sure you have heard a lot of controversy about this. A lot of people, quote, don't believe, end quote, in climate change. I don't think people actually don't believe that something's happening, but I think a lot of people are trying to understand whether this is just a natural cyclical kind of increase in temperature, or if this is, something that's really important and something that's unprecedented in history. So this is the fundamental basis for climate change, is that greenhouse gas concentrations are increasing and that this will lead to global warming. This is hard to dispute. I mean, this fact that greenhouse gases are increasing at a really fast rate, we kind of understand that's going to increase the temperature. So that's not really a dispute. But this is the dispute, and one of those disputes is it's unclear how much world temperatures will increase for a given change in greenhouse gases. So some people think, you know what, yeah, we'll increase the temperature a little bit, but we're not too worried about 50 years from now. A lot of scientists, though, are saying we should be worried about 50 years from now or 20 years from now. And yeah, it depends on how you think of it in terms of a feedback loop. So I'm going to... Yeah, let's go to this next slide. So this just shows a lot of different types of likelihoods that scientists believe that will happen. So for example, this says phenomena and direction of trend: warmer and fewer cold days and nights over most land areas. Very likely that this would occur in the late 20th century. Likelihood of future trends based on projections for 21st century. This one is like, yes, this is virtually certain. This is going to keep happening. But if you go down to some of these other ones, intense tropical cyclone activity increases. These is what they believe, but they're not as certain with some of these type of phenomenon. But this is kind of the consensus that the scientists are trying to work with. They're trying to make their best consensus off the data they have and their projections going forward. So yeah, it's not a black and white discussion. However, it's still very concerning considering the real-world consequences that could happen because of global increased CO2 concentrations and greenhouse gas emissions in general. So, what has been done about it? Well, the book first mentions the Kyoto Protocol, which is quite outdated at this point, and this was way back in 1997. And countries came together, tried to discuss putting caps and limits on their CO2 emissions. So trying to limit the amount of CO2 and trying to mitigate some of this global warming that the scientists agreed was happening. So they said, okay, for industrialized countries, like the really big ones like America and the really modern countries, they wanted to reduce their greenhouse gases to 5.2% below the 1990 levels by 2012. So again, this is obviously passed. Importantly, though, developing nations, they considered China and India as developing nations back then, which is no longer something. No, they are powerhouses. So they didn't have any emission limits back then. So not in the Kyoto Protocol, at least. But a lot of other countries did. And how are they doing that? Well, again, this book only touches on a few, but one is literally taking CO2 out of the atmosphere. So one thing you can do there is agricultural soils. If you plant things that need CO2, they will utilize the CO2 and take it out of the atmosphere. Also, retiring agricultural land and just allowing it to become natural pasture forest that lets the whole system thrive. So you're not constantly pulling the vegetables out of the ground and having to replant them. So things like that, trying to sequester the carbon in actual plants. There's other ways we can try to do this too, though. So one way is capturing CO2 from the air and emission sources, such as like the power stations themselves. So as you actually produce the greenhouse gases out of the smokestacks, instead of letting it go into the atmosphere, you're actually trying to grab that and put it somewhere. Problem is, it's not super easy to do, but there are empty, abandoned oil wells. So there's these pockets underneath the earth that we could actually store the compressed CO2 and just keep it there, or really deep in the ocean, underground, deep ocean wells. There's places that we can try to put the CO2. Now, these are ways looking at after the fact. This is saying, well, if we can't decrease the emissions, can we at least sequester the carbon? So yeah, this is one way to try to mitigate that. But ideally, you would also try to just decrease the emissions. Change the way you're getting your energy, looking to more green energy that does not produce any CO2 emissions. So that's the other side of it. This is how some of this might work. They just depicted this. So, for example, you have lots and lots of new vegetation naturally taking the CO2 out of the air. Here is our coal-burning power plant producing lots of CO2. So instead of this, we try to sequester it and pump it into these old reservoirs. So natural gas or coal mine reservoirs, all these pockets beneath the earth, this massive, massive, massive area can fit so much into that. Or these deep sea aquifers, so really deep down, put it down into there. And then also these scrubbers, these atmospheric CO2 scrubbers. These are things that try to sequester the CO2 itself in these types of filters, things like that. Or you can take it, if you're going to do really ocean floor stuff, you'll need to put it into an oil rig and pump it back into those empty wells. So a lot of talk about sequestration. But again, this is a very complicated topic. So now we're trying to think of, besides just reducing, how can we sequester it, and also developing new technologies that don't utilize fossil fuels. I mean, that really would be the key to decreasing the amount of greenhouse gases, is decrease the amount of combustion we're actually doing. So to do that, we need different types of energy sources: solar power, wind power, electrical power. However, though, if you're going to go all electric, you need to remember, how am I actually charging my batteries? Well, if you're using a coal power plant to produce electricity to charge your batteries, you're still producing a lot of CO2. So it's a complicated matter. But that is the end of our discussion on global climate change and alteration. You got some review questions here in the back to help you study for the exam. And again, these will be up on the course website for you to go through. And let me just scroll through these and make sure that you can see them all in the presentation here. And yeah, this one I didn't mention. I mentioned last time I didn't have the photo, but remember what the feedback loop is. That means increasing CO2 warms the earth, earth warming warms the ocean, and then the ocean releases CO2. And that has a really big feedback into itself. So that is an issue. And then the Kyoto Protocol, and then a little bit of talk about carbon sequestration. All right, there you go. We finished chapter 14, and tomorrow we will start our next chapter. See you guys then.